Okay, so I'm going to be going over question number 1. In this question, I've got a spring attached to a wall, and that spring is also attached to a mass. It says that the spring is stretched a distance A, and when it's released, it has a transfer of spring energy and kinetic energy. So it moves back and forth along this path. Now, they tell us the spring force, which notice it is not Hooke's law. If it was Hooke's law, it would be linear. This is what the force times distance graph would look like if it was Hooke's law, but instead it looks like this. And taking the area under the curve of this exponential function is going to require some calculus. So let's start with finding the potential energy. Luckily, we do have an equation with potential energy U and F in it. So that's going to be du dx is equal to the opposite of your force. So that would give me, I have a negative kx squared, so that's going to turn this into a positive kx squared. Or if you minus a negative, you could turn it into a positive. And then I am going to take this dx and this x, I want to bring them together, so I'm going to multiply it to the other side, and I get du is equal to k x squared dx. Now I left a space here because I know that I'm going to have to take the integral of both sides because I have du and dx in there. And so I take the integral and I made some space because the k is a constant and I can leave constants out of the integral. And then from there I can solve the antiderivative of du is u. K is just a constant. The integral of x squared is x cubed over 3. And then that is my function for the spring energy. The next question asks to determine the maximum potential energy of the spring. And it tells you that the spring is stretched a distance A. That would give you the maximum potential energy of the spring. So all I have to do is take this A, plug it into my distance, and I get U max is equal to K A cubed over 3. The next question says to determine the maximum speed of the block. Well, if I have my maximum stretch, that energy, if I stretch my spring all the way, it's going to be all spring energy, and then it's going to transfer to all kinetic energy when it is the spring is in equilibrium. And then when the spring compresses, it slows the kinetic energy down, and vice versa. So it goes back and forth between full spring energy and full kinetic energy. So from there, I just use the spring equation. I'm going to do K over 3 x cubed is equal to 1/2 mv squared. I'm solving for velocity, so I multiply the 2 to both sides, and I divide the m from both sides. These end up canceling out, and I get v squared is equal to 2k x cubed over 3m. I brought this down into the denominator, and that gave me that value. Of course, I still have to take the square root, so v is equal to the square root of 2kx cubed over 3m. The last question asks us to determine the location where the potential energy equals the kinetic energy. So I have K is equal to US, that's 1/2 mv squared is equal to 1/3 kx cubed. The only problem is that I can't set any kinetic energy equal to spring energy. I would have to figure out the total energy, which I know is this. Energy total is equal to Ka cubed over 3, and based on conservation of energy, it's always going to equal Ka cubed over 3 in the middle of its motion. So whatever the kinetic energy is, it's going to add up to the spring energy, and it's always going to equal the total here. So I'm going to take this K over 3 A cubed is equal to 1/2 mv squared plus K over 3x cubed. And since I'm solving for the location, I need to solve for x. I'm going to try to get rid of this velocity. So you can either set both equations equal to velocity and then equal to each other, but since they're pretty complex equations, I'm going to solve this equation for velocity and then plug it into this velocity. So I'm going to take mv squared is equal to, I multiply the 2 over, 2/3 kx cubed, divide my mass, so v squared is equal to 2kx cubed over m. And I'm not going to take the square root because I need the v squared here. So I'm going to take my K over 3a cubed is equal to 1/2 m times 2kx cubed over m plus k cubed over x. K over 3 times x cubed. And what's nice is my m's cancel out, my 2's cancel out, and I end up with K over 3a cubed is equal to K Oh, I lost a 3 here. Sorry. This 2/3, I lost my thirds. So I need a third here. And I knew something didn't look right. So it should be 2x cubed over 3 plus kx cubed over 3. I end up with ka cubed over 3 is equal to 2k x cubed over 3. And then I need to solve for x. This should be a 3. So first thing I'm going to do, I've got 3's in the denominator. I can multiply both sides by 3. I've got a k, so I can cancel out the k's in the numerator. And I end up with a cubed over 2 is equal to x cubed. Take the cube root of both sides to cancel the cubed, and I get x is equal to the, let me pull out the a first, a cubed root of 1 over 2. And that is going to be your final answer.